Okay, the agenda for today's talk. Firstly, I will be introducing Python and Jython and talking briefly through the differences between them and how you can easily use Jython to query data from your cloud data warehouse. I'll then look in detail at some Python do's and don'ts, so performing ELT not ETL, being careful about managing memory, and then looking at how Matillion uses Python to set variables and how useful Python can be at manipulating fields like data types. I'll then step through some examples of how you can start to use Python to integrate to other services, so to give you control over your cloud environment using the Boto3 libraries. And then I'll show you how you can optimize the performance of your Python by executing it remotely, and even ways you can execute your code without having to build specific resources. So I'm logged into the Matillion tool now. As you can see, we have a Python component which you can use within your orchestration jobs. Within the properties of the component, you can select which interpreter you want to use, so the Jython or the Python interpreters. And one of the useful features of using Jython within Matillion is that you can easily access your cloud data warehouse. So here I'm defining a cursor in the current context. I'm executing a SQL statement against that cursor. Then I'm fetching some values back, and I'm using that to set a variable in Matillion. So here I've defined a job variable, JB product row count, and I'm setting that variable based on the results of the cursor. So if I run this, I can see that I've got 8 rows in my dim product table, and that will be assigned to a variable in Matillion that I can use within my other components called JB product row count. Another way of actually performing this functionality rather than using a Python component, so we have a query results to scalar component. So here you could just put in your SQL query directly and then assign that to a variable within the component. Or if you wanted to bring multiple values back from your query, you could use our query results to grid component. So here you can map your columns from a table or from a view where you have a query, and you can map those to a grid variable to bring back multiple columns. So just a few points to note on using Jython and database access in Matillion. So the connection is made automatically for you using the current environment defined in the Matillion, and this connection will be closed automatically after the script terminates. So this feature is really provided for convenience, and it's not designed for retrieving large amounts of data. And in the next slide, we'll talk about the differences between ELT and ETL. If you execute database updates using this approach, you should not try and commit or roll back those updates. There are specific components in Matillion you can use within your orchestration jobs to perform that. And don't forget, we do have a number of components which might help you here, so the query results to scalar and the query results to grid components. Many of you who are familiar with Matillion will have probably seen this diagram before, but I just wanted to show this slide as it does become relevant when you're writing and running Python within your architecture. So Matillion promotes a push-down approach to your processing. So as you develop your transformations and orchestrations, Matillion will attempt to implement those in the most optimal way. That means leveraging the performance of the modern-day cloud data warehouse, which provide massively parallel processing capabilities. So it's important to consider this in your design of Python. What you want to try and avoid is querying and processing data outside of your data warehouse, as this could be inefficient. And while it may perform on small amounts of data, as your data grows, it's not going to be as easy to scale. The things to think about here are, can I perform the data manipulation within a transformation job? And if that is going to be difficult, can I use Python to help me drive transformation rather than extracting all of the data, processing it outside of my warehouse, and then writing the results back again? important thing to consider when you're writing Python programs is to be careful about memory management. It's very easy to generate out-of-memory errors, which are going to impact the processing across your entire Matillion instance. So here I have a very simple example where just a few lines of code can actually cause an out-of-memory error on the server. So as mentioned in the previous slide, be careful about the amount of data you return your cursor and the processes you want to perform on the instance. In the final part of the talk, I'll highlight a way you can isolate this risk by executing your Python remotely. Something that Python is really useful for is developing small scripts to help with the implementation of more complex logic and decisions. So I'm going to talk through a simple scheduling example, which will show you how you can manipulate dates in Python and integrate that with variables in Matillion to help you implement your processes. So I'm in Matillion. Here, and if for example I wanted to execute a job every other Tuesday, I could use a Python script to help me define that schedule. So within my orchestration job, the first component I'm going to run is a Python component, which is going to do some manipulation of dates. And pass values back to Matillion to allow me to control the flow through the rest of my orchestration process. So here within the Python component, I'm using the Python 3 interpreter. The first thing I'm doing is importing the date time library so I can access date time objects and functionality. And then executing the now method on the datetime object, and that's going to return today's date, and I'm assigning that within my Python script. To a variable called today, I'm then executing another method against my variable today. This is a format specifier, and this is going to return to me the week of the year. So I'm assigning that into another variable within my Python script called week of year. I'm then going to do a calculation on that variable. So I'm going to divide it by 2, but I'm going to use the modulus operator here. So I know that if the result is 0, then I know that my week of year is even. So I'm going to set that to a variable called week is. I'm going to set to even. Otherwise, I'm going to set that to odd. And then finally, I'm going to print my variable. This will allow me to see the value of that variable in the task history in Matillion. But I'm also going to update the job variable in Matillion. So I'm going to set the JV_weekIs job variable to the results of my weekIs variable from my Python script. So I have 2 variables here defined within my job. So if I go into manage job variables, you can see I've set up 2 variables here, JV day of week and JV week is. And then within my Python script, I'm setting those variables. So the final variable I'm setting here is I'm calculating the day of the week, and I'm setting that to the JV day of the week variable within my Python script. I can then reference these variables within my job. So I'm using a if component here. So I'm saying if the week is even, i.e. the results that have been set in my Python script, if the week is even and the day of the week is equal to 1, then I'm going to execute my job to process the data. Otherwise, I'm just going to end this orchestration process. One of the key advantages of Python as a simple scripting language is that it enables you to easily integrate with other services. So I'm going to show you a couple of examples using the Boto and Boto 3 libraries that enable you to integrate with other services within your AWS cloud environment. So here in Matillion, I've got a simple orchestration job. And again, I'm just running a Python component here. And within that Python component, I'm importing the Boto 3 libraries. So this is going to allow me to connect to my S3 buckets or other services within my AWS cloud account. So I'm connecting to my S3 buckets, my cloud storage. I'm passing in here, I'm using a job variable, which I've set within the orchestration job. So I'm passing that in to obtain the key for my source bucket and my destination bucket. And then I'm going to copy files from my source to my destination buckets. So I could use this approach throughout my orchestration jobs to start managing the files within my S3 cloud environment. I'm logged into the AWS console here, and you can see I have a Lambda function defined, and I have an S3 trigger associated with that Lambda function. So when a file arrives within my S3 cloud storage location, it's going to execute my Lambda function. So within my Lambda function, I just have a Python script. I'm importing the Boto 3 libraries, and that's going to enable me to integrate with some of the AWS cloud storage services. So I can integrate with the SQS message queues. And here I'm building a message that is going to enable me to execute my job within Matillion. So I'm passing in the group, project, version, environment, and job that I want to run within my Matillion instance. And I'm also passing in a variable, which is going to be the file I want to load. So here in Matillion, I have my orchestration job. and this is going to load my file from the S3 location and perform some transformations within my data warehouse. So I've configured Matillion here to listen to the SQS. So here it's going to take the messages from the SQS. I've defined an environment variable, which is going to be my file to load. And so within the data load, I've referenced this variable. So when this job is triggered by the SQS, it passes in the message, the name of the file that I want to load. And then this job is going to pick that file up, load it into my data warehouse, into my target table, and perform the transformations to move that data on through my data warehouse. There are some circumstances where the amount of processing required by the Python script means it can be more sensible to run the Python script elsewhere to minimize the impact on the rest of the Matillion server. This might be because the Python script requires a large amount of processing power, which may affect the resources in the Matillion instance, which is used to host the Matillion application, or because of corporate requirements around security or execution isolation. Examples of where this is the case include processing large files, such as running XML to JSON conversion, compressing or uncompressing large files, or running API calls that require or return a lot of data. There are a number of different ways you can do this, and I'm going to highlight a few examples on AWS, but some of these principles can be applied to other platforms. So it's possible to run scripts remotely on another EC2 instance using an SSH command to connect to that instance. We could execute it remotely using a Lambda function without worrying about creating servers, or we could use AWS Glue to create and run Python shell jobs. So here I have an example of executing a Python script remotely using SSH. So rather than using the Python component, I'm actually using a bash script component. And within that bash script, I'm executing an SSH command. So I'm passing my Python script through to that SSH command using an inline approach here. So when this Python script executes, it's actually going to execute on my remote server here. I can pass in Matillion variables to this script, and these will be resolved before the script executes. So some of the advantages of using this technique is that I have control over the memory allocated on the remote server to run my Python script. I can maintain my remote server separately, so I can maintain the libraries and the version of Python without affecting my Matillion server. Some of the disadvantages include, obviously, I need to maintain and the cost of running a separate server to run my Python scripts. I can't reuse the connection into Redshift to run queries against my cloud data warehouse, although I could set up a new connection within my Python script. And you can't actually update Matillion variables within the Python script. So here I have another example of executing a Python script remotely, but this time using a Lambda function in AWS. So rather than using a Python component, again, I'm using a bash script component. And within that bash script component, I'm using the AWS command line interface. So using that interface, I'm able to create Lambda functions in AWS. So I have a Python script on my Matillion server in the temp directory. I'm going to use that to actually create the Lambda function, and then I'm actually going to run the Lambda function. Once the function is complete, then I'm going to delete that function ready for the next execution. So the advantages of using Lambda functions is there's no need to worry about servers. So you don't have to maintain separate servers. You can just pay for the compute resource you use. Disadvantages include the scripts can't run for more than 15 minutes. You have to set up a IAM policy, the AWS Lambda Basic Execution Role. If you have any dependencies within your script, they must be done by having all the dependencies locally and packaging them with the Lambda function or using the console to install those dependencies. You can't, similar to SSH, running your scripts over SSH, you can't use the connection into Redshift, so you have to maintain that separately. The output from the function isn't displayed in the Matillion task history, so you do have to read that from the AWS console or separate file. And obviously there's a cost implication to running those as a separate service within AWS. So the final example of running my Python scripts remotely, I'm using AWS Glue. Here again, rather than using the Python script directly, I'm using a bash script component. And within my bash script component, I'm using the AWS command line interface. So I'm using this to copy my scripts to S3 and then create the actual glue job and then execute the glue job. And then I have some logging information here to retrieve the logs so I can access those within my orchestration job. You do need to set up a couple of policies to do this, the Amazon Glue service role and IAM read-only access. But similar to the Lambda execution, you don't need a separate resource to execute these jobs, although there is a cost implication for running AWS Glue jobs. So I hope you found this talk useful. Just to summarize some of the key points we've discussed. Use a push-down approach where possible. Avoid extracting data from your data warehouse, processing the data and writing back to your warehouse. Try and leverage the performance of the data warehouse engine where possible. There's a lot of rich functionality and libraries within Python that can help you build complex processes, but beware of memory usage. If you do need to run large workloads like compressing and uncompressing files or reformatting large files, look to do that in dedicated environments by running your Python remotely. And finally, Python is a great way to integrate with your other cloud services. If you need more details on the items I talked about today or support on any aspect of Matillion, then check out our blog articles on www.matillion.com/resources/blog. These provide some of the code examples that I walked through in this talk. We now have the new Matillion community site, so definitely worth checking that out.